Okay, this time we're going to look at page 180, question 7. Now, this is just the front of the shape. It's actually a volume question, as you see when you look at the question. But this is the front of the shape. And the reason we need the front of the shape mainly is because the volume equals the area of the front multiplied by what we could call the depth. Now the depth will be this distance here, which turns out to be 1.5 meters if you look at the diagram, but we'll come back to that in a minute. Now, I've changed this distance here. It says 1.2 meters on the diagram, but of course you need to have all your measurements in the same unit. So we're going to work in centimeters just now. So we're going to change that to 120. Now, there are three distinct shapes. A is a rectangle, C is a rectangle, but B is not a specific shape. But what you can say with B is that it's actually one shape on top of another. It's a triangle on top of a rectangle. So we're actually going to be working out three parts here. First and third are easy. The bit in the middle requires a little bit of extra work, but if you spot that, it's not too hard. Okay, so area A will be 20 by 50, not difficult, that gives us 1,000. Area C will be 80 by 60, which gives us 4,800, and they're both square centimetres, of course. Now, this bit here, it's this measurement here that concerns us, because we are always tempted to say, well, if that's 60, that's going to be 1330, but of course it's not, because this bit here is 20. So if that bit there is 20, this bit up here must be 40. So when we have our triangle has a height of 40 and a length of 120, and a rectangle underneath it is 120 by 20. So if you can see that, that makes all the difference in the world. So area B will now be the triangle, which will be 120 by 40. Remember, the area of a triangle is length times breadth divided by 2. So that's 120 multiplied by 40 divided by 2, which gives us 2,400. And the rectangle as part of area A is just length times breadth, so that's 120 by 20, so that's, ironically enough, 2,400 as well. And again, they're both in square centimetres. And then if we total, the total area turns out to be 10,800. Is it 10,800? 10,600 square centimetres, just by adding those four together. Right, but that's not the end of the question, because the volume is the area times the depth. Now, we mentioned at the start, this depth here is 1.5 metres, which is of course 150 centimetres. So that's going to be 10,600 multiplied by 150, which gives us 1,590,000 cubic centimetres. But unfortunately, we've got to give the answer in cubic metres. Now, maybe we should have thought about that at the beginning and given all the measurements in metres, but if you do that, you end up with horrible decimals all the way through. So here's how we deal with it. A cubic metre is a metre by a metre by a metre. That's what a cubic metre means. So if you've got a cubic metre is 1 metre by 1 metre by 1 metre. Now, if that's okay, then you can change to centimetres. So that's 100 by 100 by 100. So that turns out to be 1,000,000 cubic centimetres. So if we want to work out the volume in cubic centimetres, we have it here, but if we want to change that to cubic metres, we're going to have to divide by 1,000,000. So the volume is 1,590,000 divided by 1,000,000. Now that's 1,000,000, so we're just going to move the decimal point back 6 places, and that will give us 1.59 cubic metres. Now that's tricky. We could have started off by saying make all these measurements metres, but to be honest, I think that's harder. So we're more comfortable working with big numbers, and then when we get a final answer, that's how we convert it. Okay.